Undefined.
What do undefined values from algebra 2, what do those look like on graphs?
Holes.
Either holes or vertical asymptotes. And you may remember from algebra 2, if you had a number over 0, it made a vertical asymptote. Would you agree all of those were numbers over 0?
Yeah. Yes.
So those are all vertical asymptotes. So cosecant has a lot of vertical asymptotes. At 0, it has a vertical asymptote. At I, just for fun, I'm going to graph a sine function for a moment. I'm going to show you some parallels between sine. So that's what a sine function looks like. That's a sine function. Cosecant at pi over 4 is radical 2. So what is radical 2? Someone with a calculator. It's more than 1, isn't it? It's like 1.4-ish. So it's pi over 2. So over here, I'm up here a little bit. Okay. And then at pi over 2, 1. So just like sine, that value is there on cosecant. And then at 3 pi over 4, it's not equal to it. And if those are truly vertical asymptotes, wouldn't I approach them? So the green graph is cosecant. And then over here, -1 here, right? And I'm going to approach those vertical asymptotes something like that. If you will, just for fun, in your calculator, type 1 over sine of x and y equals in this graph.
What was it?
1 over sine of x in your. What am I graphing if I type 1 over sine of x in my calculator?
The inverse of sine of x.
No, close. Cosecant. And the inverse is sine inverse, which is a little different than cosecant. Reciprocal. I knew what you meant. So which graph? Go to zoom trig, and that'll make a decent window so you can see it. I don't know where your zoom trig button is. If you haven't learned it yet, it's coming. Zoom 7. Say, what's it look like? Use. Yeah, a bunch of views. Doesn't it look like this green stuff here? Okay, now, how can I graph it? Well, if I use sine, wouldn't that be very helpful? Everywhere sine has a peak, I'm going to go up, and everywhere sine has a valley, I'm going to go down, and I've got asymptotes everywhere sine is 0. Does it make sense that I would have asymptotes everywhere sine was 0? Because the reciprocal would cause a problem. Today we're going to look at the cosecant function and the secant function. This is cosecant. Every time I graph a cosecant function, I'm going to graph a sine function so that I can tell where it goes right there. Not everyone teaches it that way, but for me it's very helpful because I kind of get to use something I already do. And then I can draw those views from there. The graph has a lot of what are called discontinuities, places where you have to pick up your pencil to draw it at every interval of pi, 0, pi, 2 pi, 3 pi. They said it pi in, pi times n. So they're just saying every pi, this has a vertical asymptote. There are no x-intercepts. So if you ever have a unit circle type quiz again, and it asks you for a cosecant value, is the answer ever 0? No, it doesn't. It's never 0 across the x-axis. So I don't know, a few of you did unit circle quizzes, and I looked at it with cosecant's not 0. I didn't even have to think about it. Now you know why. I know cosecant's not 0 because the graph does not cross the x-axis. The period is still 2 pi. It takes 2 pi for it to repeat because it's a reciprocal of sine. It doesn't have an official what's called amplitude. We will still kind of think about amplitude. We'll still talk about amplitude, but just know it's really not amplitude anymore. because this graph does not have a maximum value. Does that make sense? It continues on forever. So there's no technical amplitude. Again, we'll kind of talk about the A value, but it's not really amplitude. The graph is symmetric with respect to the origin. It's called an odd function. Sine is also called, and we talked about that on the sine day, but I kind of breezed over it. If I took this graph and rotated it 180 degrees around the origin, it would land on itself, so it's an odd function for origin symmetry this way. The domain of this function, you can write it a bunch of different ways, but x cannot be the multiples of pi. So the domain is broken up because x can't be a multiple of pi. And a range, what is the range? There are a lot of people. So I'll use interval notation if I'm doing a lot of points. Lowest y value, negative infinity. So the range is everything except the values between -1 and 1. Any questions about the domain of range? So that's a cosecant function. Very similar to sine and cosine once I know the cosecant function. The secant function is the exact same thing, except I'm going to quickly draw a little cosine function in here. Right, you see the difference? When cosine is 0, I have a vertical asymptote, and when cosine is 1, it goes up, and when cosine is -1, it's one of those U's going down. The domain is all of the x's except the multiples of pi over 2. Does that make sense? It can't be pi over 2, can't be 3 pi over 2, can't be 5 pi over 2, so the odd multiples of pi over 2. And arranges everything except the numbers between -1 and 1. Other than that, this says very similar things. There are no x-intercepts, periods 2 pi, no amplitude. And this one is symmetric with respect to the y-axis. It's called an even function. So it's cosine. So these are the secant and cosecant functions. So we're going to learn how to graph secant and cosecant functions. The domain. And so this little thing, I think it lost. But x can't be odd multiples of pi over 2. But 2 and plus 1 is just all the odd numbers. It's 2 times the number plus 1 would be the number. So it's just all the odd numbers. So again, our main focus is going to be graphing. If you use the calculator, I just showed you that already, so probably don't have to write this down, but to graph cosecant, you'll use 1 over sine of x. To graph secant, you'll do 1 over cosine of x if you're using a calculator. It does get tricky when you have a bunch of different things going on. You would leave the amplitude on top. I know it's not really called amplitude, but you'd leave the A on top. Everything that's inside, you leave inside, and then the plus, the vertical shift would still be outside. So it's a little weird on rewriting. Let's just, I'll show you one thing. Okay, to graph this, and this is the textbook words, so I may say them a little differently. To graph a cosecant of bx, I'm going to graph a sine of bx, and I'm going to use it as a guide. Everywhere it has a 0, it's going to have a vertical asymptote. Everywhere it has a 1, it's going to have a u up, and everywhere it has a -1, it's going to have a negative down. Same thing for cosine. I'm going to graph cosine for secant. The first thing I'm going to do is sketch finish the vertical asymptotes, and then I'm going to draw what this textbook called the U-shaped branches. I'm going to graph the corresponding sine and cosine graph. I'm going to graph vertical asymptotes. I'm going to graph the U's. So that's the gist of what that slide is. So I have 3 secant of 2x. Now I'm going to graph that. I'm going to see what 3 cosine of 2x looks like. And I'm going to use that to graph 3 secant of 2x. If 2 is what's the first question asked when such a graph cosine? What's the period and what's the amplitude? So the period of the cosine graph is pi, the amplitude of the cosine graph is 3. So that's the first thing I'm going to think about. I'm going to graph it. I'm going to graph the cosine function first. This is not secant, but it will help me a whole lot. First thing I'm going to do is graph the cosine function. You can fully draw the whole thing if you want to, or just putting the points there would probably be enough. I'm going to go ahead and draw the whole thing. Putting the points there would probably be what you would need to do. Draw as many periods of cosine as you will need periods of secant. This one didn't say, but if you need 2 periods of secant, draw 2 periods of cosine. Everywhere cosine crosses the x-axis, I'm going to put a vertical axis. Now notice those are in different places because I have a horizontal shrink. But that's okay. This figures out where those places are. So there, on this one, it's pi over 4 and 3 pi over 4 instead of pi over 2 and 3 pi over 2. Everywhere there is a 1. In this case, it's a 3, right? Because they change it a, the first touch. I'm going to draw an upward facing U. Where there's a negative 1, I'm going to draw it downward facing U. That's 1 full period of secant, 3 secant 2. I mean, you can kind of tell what would happen if you kept going left or right. You finish those U's off, but that's one full period. Remember, these graphs do go on infinitely if it doesn't, if there's not, you wanted to graph more, but 1 period is enough unless it's much better. Any questions about this one? Does it make sense how to graph cosecant? Once you know sine, cosine, it's not too bad here. It's too big lesson. I guess that's how far I got last time. I do have more work on that later. Okay. Cool. Okay. What does this one have? It has an amplitude. Remember, we're saying that word. We know we're wrong, but we're going to say it anyway. It's fine. Right? The amplitude of the regular sine function. Then I'm going to take that sine function. This is my favorite way to do it, but you can do it however you want to. I'm going to go ahead and pick it up and move it left or right. I am going to move this left pi over 4, which is how many tick marks? Half of a tick mark, right? Because each tick mark's pi over 2. Is everyone okay with how they do that? This is pi, so that's pi over 2. Half pi over 2 is pi over 4. Throw some extra tick marks. And moving left, pi over 4. So I'm going to pick each one of those points up and move it left pi over 4. Even if there is a vertical shift, I'm going to stop here and draw my cosecant graph. Because it's easy to see when it's still sitting on the x-axis where the vertical asymptotes go. Once you move it up off the x-axis, it gets a little tougher to see that. Does that make sense? So go ahead and do the cosecant graph before any vertical shifting. So after you horizontally shift, then go ahead and draw your cosecant graph. Remember, this crosses the x-axis. I have a vertical asymptote. And again, if you needed more periods, draw more periods again. I would recommend secant and cosecant. If it tells you to graph from and to, like from negative pi to pi, I would graph extra and then go back and erase. So you're going to know what I mean by that. If it says to go from a specific negative pi to pi, I'd graph bigger than that and then just go back and erase wherever you need it to. Any questions so far? Let's write an equation for the graph. To me, it would be helpful to do a quick sketch of a sine or cosine graph before I try to decide which one it is. Looks like this is at -2 and that's at 0, so that's going to be the center. Okay. Any questions so far? What type of function would I choose? Sine, which means I'm really choosing cosecant. So this is a cosecant function. Did it help to draw that little sketch before to decide that? So the cosecant function, what is the period? How long does it take for a full cycle to happen? 2 pi. Why 2 pi? This is only half of one. It's only 1 u. Full cycle is 1 u up and 1 u down, right? So the period is 2 pi, so there's no period change. What's the amplitude? I know that's not the right word, but we'll call it that. It's 1, right? It's just 1, so the -1 would flip it. So it's amplitude 1. So far, it's just a plain cosecant of x graph, right? What is the one transformation this graph has? It's shifted down. It looks longer, but since the period's 2 pi, it must not be. It must just be because I just figured the graph. Any questions about that? So it's your formula. And there's one with a vertical shift also. This is due on Tuesday. On Monday, you'll have some time to work in class. I may go ahead and start the next lesson on Monday. multiple graphs on your paper again somehow, either highlight or use a red color or some other color on the final graph, or just say final answer, do something like that. If you can do it in your head, that's great, but I have no expectation that you have to do any of that in your head. So I'm going to do this right pi over 2, which is how far? How far is pi over 2 with the same? Why is it 2 tick marks? Pi is here, so half of it would be here. So that's 2 tick marks. So I'm going to pick each one up and move it 2 tick marks over. Oh, I should have done. What should I have done from the beginning? Good idea. What am I doing?
2 periods.
Why am I doing 2 periods? The problem is I didn't see that first that part. You'll forgive me, I'm sure. Do what? Okay, any questions so far? So the red graph, again, you don't actually have to connect these dots if you don't want to. But the red graph is the cosine graph with the correct period, amplitude, and phase shift. I'm going to stop at this point. I'm going to go ahead and do the cosecant part of it. Don't forget, we have not finished transforming. That it is just so much easier if those are sitting on the x-axis to find the vertical asymptotes. Now, you are pretty smart people. You probably could get away with now kind of transforming as you draw. We're moving it up 1 unit, so this is, right, instead of putting it on the red dot, I'm going to put it 1 unit above the red dot. Right? So, if you can't do that, it's okay. You can draw it and then shift it, and that's fine. 1 unit above the red dot. But I do still have to go down, right? Just shifting it up. 1 unit above the red dot. And 1 unit above. So that is my cosecant graph. Okay. Any questions? Or secant graph. I have some more grid paper. That trig grid paper. If anyone wants it, I'll let you pick some up. If you prefer doing it on your own paper, I'm okay with that too. But if you do want some trig grid paper, we'll probably get the book out and we can see how many pieces you need. How many graphs are on this. Just the ones that you have to graph it. If it